Now let's do one that's a little bit more difficult. So this one's still going to be the same type of thing. We're going to look at two equations with two variables. Sometimes they call it two unknowns, means the same thing, but two equations, two variables, x and y in this particular case. And what we're going to do with this is we're going to plug one into the other. So we know that this is equation one. Hold on. This is equation one. This is equation two. Notice that it's easier to plug this into our y value over here because we've already solved for y. So we have to always solve for one variable and then plug it into the other equation. So we always want to figure out which variable is the easiest one to solve for. Notice that these have fractions. Even if we had solved for a different variable, we'd still have quite a bit of fractions. So we want to be careful about how we solve this and what it is that we need to do when going into these types of problems. So here we have it solved. Well, ready to solve. So we're going to plug it in. So first step is that I actually plug it in. So I have 8 times x plus 12 times y, but my y value, I'm going to erase that because I want it to be in blue. But my y value is 1/4 x minus 1/2, and then that's my y value, and then that equals negative 1/2. Notice that it replaced the y that's right there. Okay, so that's what we have there is we've got that particular one as we solve for it. So now what we're going to do is we're going to go ahead and solve for x. So notice I have an x here and an x here. I'm going to solve for it. The first thing I have to do is distribute. So I'm going to leave the 8x alone. Can't add these together. Number one, because they don't both have an x, and number two, because order of operations tells me to multiply first. And this is 12 times that, so I have to multiply first. So then plus, then we have 12 times 4. 12 times 4 is, 12 times 1/4 is 3. So that would be 3x. And then we have 12 times negative 1/2, or 12 divided by negative 2. So we have negative 6 here. And then we have that equals negative 1/2. Okay, so it's easy to do that part. We're going to have easier to do that part. So we have 11x minus 6 equals negative 1/2. Now remember, I don't like to work with fractions, so I'm going to look for a common denominator in all of these terms here. Remember, this is over 1, this is over 1. So my common denominator would be 1 times 1 times 2, or 2 would be my common denominator. So that means I'm going to multiply everything by 2. So multiplying everything by 2, I get 22x minus 12 equals negative 1. And notice in the last case, the 2's cancel each other, so we end up with negative 1. So then we add 12 to both sides. When I add 12, I get 22x equals 11. Divide both sides by 22, and not 2x. And finally, then these two cancel. X equals 11 over 22, which is really just 1/2. So x would be 1/2. So there's my x value, and now I need to find my y value. Now notice that if I have an x value, go back up and look at the equations. Notice this one's already solved for y. So y equals 1/4 x minus 1. So y equals 1/4 x minus 1/2, not 1. And what I'm going to do is I'm going to plug it in there. So I'm going to plug that value in there. So I'm going to rewrite my equation. I'm going to rewrite it just below it. So I have y equals 1/4 times 1/2 minus 1/2. I'm going to erase this because I'm going to put it in blue so you can see where I substituted in. So if I go back over here, I have, so I plugged in a 1/2. Notice that I plugged in a 1/2 for x. So that's what I did there. Okay, so 1/4 times 1/2 is 1/8 minus 1/2. I have to have a common denominator, so that's 1/8. And my common denominator is 8. So we look at 2 goes into 8 4 times. So then 4 times 1 is 4. So I have 1/8 minus 4 over 8, which is negative 3 over 8. So that would be my answer. All right, now, so we have special cases. So now we've got a special case that I kind of want to walk through, and I want to show you that in this particular example, there might be things that cancel out that we don't expect to cancel out, but they do. And so that's why it's considered a special case. So notice here, I have 3x plus y equals negative 5. Now, I don't have either equation solved for just one variable. Notice that the variables are on the same side, so they're together, so I have to solve. So I would have to divide by 3. I'd have to divide by 6. I'd have to divide by 2, which means that I could potentially have fractions to solve them. So it's easiest to solve for the y here. So you notice that I can subtract 3x from both sides. Okay, not divide, but I can subtract 3x from both sides. And when I do that, of course, these go to 0. So I get y equals, and I have negative 3x minus 5. And remember, I cannot combine unlike terms there. They are not like terms, so I can't combine them. And now what I'm going to do is I'm going to plug this into this equation right here. So to do that, I have 6x plus 2, I did my times again, plus 2 times, now I'm going to plug it in, negative 3x minus 5 equals 10. So notice that where I put a y there, notice that I plugged in my value there. So that's how you plug things in. And now we're going to solve it. So we're going to distribute. So I have 6x minus 6x minus 10 equals positive 10. Notice that these two cancel. It becomes 0. Okay, not 1 and not 0x. It becomes 0. So I end up with an answer of negative 10 equals 10. Now I don't have a variable to solve for. When I don't have a variable to solve for, you have to decide, is it true or is it false? Well, negative 10 can never equal positive 10, so therefore it would be false. And when it's false, that means that the two lines are parallel. That means that they never cross. Okay, so they never cross in that particular case. Now, if, for example, positive 10 equals positive 10, and that's true, that means they are the same line. So there's two things that you can get when you're doing that. You can get that they are parallel, or you can get a solution. You can get that they are parallel, or you can get that they are perpendicular. So actually 3 different potential solutions that you have. And I'm going to stop there. This problem works out very similarly to this one here, so I'm not going to go through this one. And that's what we've got.